Good afternoon, everyone. This is Ken Jasperby, and today I am going to tackle the subtopic of stoichiometry. The learning objectives of this lesson are apply a specific problem-solving method to successfully answer the stoichiometry problem, balance a chemical equation using whole number coefficient, classify a reaction as either synthesis, decomposition, single placement, double replacement, or combustion based on its chemical equation. So, what it means when we say stoichiometry? Stoichiometry is a section of chemistry that involves using relationship between reactants and products in a chemical reaction to determine desired quantitative data. In Greek, stoichon means elements and metron means measured. So, stoichiometry literally translated means the measure of elements. In order to use stoichiometry to run calculations about chemical reaction, it is important to first understand the relationship that exists between products and reactants and why they exist, which require understanding how to balance reactions. So let's go to stoichiometry subtopic. Third is the molecular formulas tell you how many atoms of each element are in a compound. And empirical formulas tell you the simplest or most reduced ratio of elements in a compound. If a compound's molecular formula cannot be reduced anymore, then the empirical formula is the same as the molecular formula. The example of this is the mercury chloride. Mercury forms a compound with chlorine that is 73.9% mercury and 26.1% chlorine by mass. What is the empirical formula? Let's say we had a 100-gram sample of its compound. The sample would therefore contain 73.9 grams of mercury and 26.1 grams of chlorine. How many moles of each atom do the individual masses represent? So, empirical formulas. An empirical formula tell us the relative ratios of different atoms in a compound. The ratios hold true on the molar level as well, thus H2O is composed of 2 atoms of hydrogen and 1 atom of oxygen. Likewise, 1.0 mole of H2O is composed of 2.0 moles of hydrogen and 1.0 mole of oxygen. The example of empirical formula is glucose. Glucose has a molecular formula of 66H12O6. It contains 2 moles of hydrogen for every mole carbon and oxygen. The empirical formula for glucose is CH2O. Next topic is a mass relationship with chemicals. Refers to the ratio of the mass of reactants and products to each other. In a balanced chemical equation, you can use the mole ratio to solve for mass in grams. You can use an equation to learn how to find the mass of a compound, provided you know the quantity of any participants in the reaction. Next is the limiting reagent. When there is not enough of one reactant in a chemical reaction, the reaction stops abruptly. To figure out the amount of product produced, it must be determined which reactant will limit the chemical reaction and which reactant is in excess. One way to find the limiting reagent is by calculating the amount of product that can be formed by each reactant. The one of the product less product is the limiting reagent. The example of limiting reagent is if 2 moles of H2 react with 1 mole of N2, then all N2 will not be used since there is insufficient H2 in one reaction. Therefore, hydrogen is the limiting reagent. Another example is consider the reaction between 2 moles of H2 and 1 mole of oxygen O2 to give 2 moles of water H2O. Lastly is the percent yield. Chemical reaction in the real world do not always go exactly as planned on paper. In the course of an experiment, many things will contribute as the formation of less product than would be predicted. Besides spills and other experimental errors, there are often losses due to an incomplete reaction. Undesirable side reaction. Chemists need a measurement that indicates how successful a reaction has been. This measurement is called the percent yield. A percent yield is a chemical reaction 0.5 grams of product is made. The maximum calculated yield is 1.6 gram. What is the percent yield of this reaction? Therefore, the percentage yield of this reaction is 31.25. To summarize all of this topic, given a chemical reaction, stoichiometry tells us what quantity of each reactant we need in order to get enough of our desired product. Because of its real-life application in chemical engineering as well as research, stoichiometry is one of the most important and fundamental topics in chemistry. Stoichiometry is the quantitative study of reactant and product in a chemical reaction. In this experiment, we can conclude the limiting reactant is the reactant in a chemical reaction that limits the amount of products that can be formed. The stoichiometry of a reaction describes the relative amounts of reactants and product in a balanced chemical reaction. A stoichiometric quantity of reactant is the amount necessary to react completely with the other reactants. Stoichiometry is a calculation of the quantities of reactants or products in a chemical reaction using the relationship found in a balanced chemical equation. The coefficient in a balanced chemical equation represent the reacting ratios of the substances in the reaction.